What's up guys, my name's Amir and today we're going to be doing a super challenging wave problem. It has two parts and part 2 is the difficult part. So in this question we have a tuning fork of frequency 512 Hz and it is traveling to the point A, and our point A is 20 meters apart. So let's draw this situation real quick. We have our tuning fork with a frequency of 512 Hz and it's making a sound that goes all the way to point A, and point A is 20 meters away from the tuning fork. So the question is, what is the time required for the wave to reach the point A? In the question they also give us the speed of sound, and the speed of sound is 340 meters per second in this case. So this is actually a simple question. People will get confused because they think it's a wave question, but it's actually a kinematics question. We have an object, or we have something traveling at 340 meters per second. How long will it take to get to the point A? We have a velocity, we have a distance, then we can easily work out the time using our speed equals distance over time formula. So that means the time is equal to the distance divided by the speed, which is equal to 20 meters divided by 340 meters per second. And that gives us approximately 0.059 seconds for the wave to reach point A. So that's part A of the question. Alright, now here comes the challenging part of the question. How many wave cycles will there be between the tuning fork and the point A if it traveled to point A? So let's try and visualize what's going on. So we have the tuning fork going all the way to point A, and it's asking how many wave cycles would there be. So it's a very high frequency, so we can think of it as something like this, and we need to count how many of these little wave cycles are we going to get before we reach the point A. So I'll let you guys have a couple seconds to think about how we're going to actually approach this question, because there's two ways that we can do it. So the first way is actually using the wavelength. So if you look at this, if you remember this whole distance is 20 meters. Right? And we can work out, if we know what the wavelength is, then we can do 20 meters divided by the wavelength of this wave, and it will tell us exactly how many waves fit from between the fork and point A. So let's start off with that method first. So the first thing we need is the wavelength of the wave. Now we have the velocity and we have the frequency, which means we can easily work out the wavelength, which is v divided by f. So we have 340 divided by 512. Now this is going to give us 0.664 meters. Now we know the full distance is 20 meters. We can divide it by the individual wavelength, which means the number of wave cycles, the number of waves is going to be the 20 meters divided by 0.664 meters. And this will give us approximately 30.1 waves. Awesome. So that's method 1. So the second way of solving the problem is actually using the period. So we know the entire journey took 0.059 seconds. So what we can do is we can actually work out the individual period. We can work out how long one wave takes and see how many of those one waves fit the entire time of journey. So to work out the period, remember we can use our reciprocal of the frequency. So we have 1 over f, which is 1 over 512 Hertz. This gives us 0.001953 seconds. So this is the time taken for just one of these little wave cycles. So now we know the entire journey is 0.059, so that means the number of waves is going to be the entire journey, which is 0.059 seconds, divided by our answer there, 0.001953 seconds. So when we work this out, we get 30.2 waves. So you can see this number is a little bit off from this number, and the reason is we actually used our rounded values, 0.059, and these are rounded values as well. Ideally, we want to use the exact value. Now, when you use the exact value, we actually get 30.1. So it's important to store your answers or write down as many decimal places as you can when you sub these numbers in so that you don't get rounding error. But that's how you solve this difficult problem. Thanks for watching that video. Were you guys able to figure out that challenging problem on your own? If you have any challenging questions, make sure to let us know and we can answer them for you. Thanks.